This is a recording of my conversation with Nick Payton, B2B market leader at Sigopt. Sigopt is one of the companies that aim to make machine learning more productive. Specifically, it helps with model optimization, and it's used by companies for which these models are at the core of the value they generate, such as algorithmic trading firms for investment models or streaming companies for recommendation models, to mention two examples. SigUp is also backed by some of the most forward-thinking VCs, such as Andreessen Horowitz. I'm talking to Nick Payton, B2B marketing leader at SigUp. SigUp mission is to empower machine learning experts to create better models faster. It is recognized as one of the most promising AI startups and is backed by some of the most well-known VC firms such as Andreessen Horowitz or Y Combinator. First, Nick, let's start with a few things about yourself, the company, and your role.
Yeah, that sounds great. First of all, thanks for having me on your show. I know we've done a few podcasts in the past, but this is actually a pleasure to be able to speak to your audience. High level for me and for Sigopt. Sigopt, as you mentioned, is specifically designing software solutions for the world's experts. And so we take a little bit of a different approach compared to other solutions that may be in our space, in that we build really tools that fundamentally augment rather than automate a lot of pieces of the workflow. And they're designed so that we can incorporate the domain expertise from machine learning engineers, data scientists, pair it with software solutions that really help them develop novel insights on their modeling problems. And then as a result, can actually produce much higher performing models with that nice combination of software and human in the loop expertise. My role, as you mentioned, I'm responsible for our marketing as well as our strategic partnerships. So on the marketing side, we work with a lot of large enterprises to solve some of their more challenging modeling problems and or integrate our product in their modeling platforms that they may be developing. On the partnership side, we partner with some of the bigger companies in the world and some of the top AI brands, whether it's Intel and NVIDIA or Google, Amazon. That's the high level in terms of my role and responsibilities here.
Before we talk more about SigUp, let's go a little bit to the basics. So how does a typical machine learning model development work? What are some of the key steps, some of the key challenges, and where do you come to help?
That's a great question. From a framing standpoint, just at a really high level, the way that we think about it here, there are a bunch of data-related steps. And when you get closer to a machine learning task itself, those steps look more like, there's a long tail of data related work, but once you get closer to the actual modeling problem that you're trying to solve, there's data preparation, certain data pipelines you may need to set up depending on what your data looks like, as well as tasks like labeling, annotation, depending on the type of machine learning job that you're doing or deep learning task that you're doing. Then the middle step is a bunch of experimentation that includes doing a little bit of feature engineering, some feature transformations, maybe doing feature selection, as well as running tasks like model training, doing training runs, and model tuning. And we bundle all of that into like an experimentation and model development step in the way that we think about it. And the final step is productionalization and deployment, where you're serving the model so that it can fit in any application, and you're instrumenting it and have monitoring in place for that model in production. Now, for SigUp, we fit in that squarely in that central middle bucket. The way our system works, we really have, to summarize it, there are three attributes within the model development process that we actually help enable. One is making sure that you can track all your work that you're doing, full experiment history. Second is training enablement, whether it's visualizing runs or whether it's using predictive stopping, or whether it's running hyperparameter tuning jobs really seamlessly with an intelligent tuning approach. You can do all of that as you're developing models in that centralized step. And you can give us as much or as little information as you want and still get value out of our product, which is why a lot of the most security sensitive companies in the world will actually use our solution. As you're actually developing models and as you're scaling your approach to model development, even going from one data scientist, one notebook, all the way up to hundreds of modelers. In fact, we work with companies that have thousands of modelers. You can actually use our product and it'll scale with your needs.
Maybe we go next to what are some of the customers, in what areas, what industries, and for what type of models is Sigopt used?
Yeah. So we're kind of unique on the models front. So our core technology for hyperparameter tuning is designed to be fully agnostic. So you can actually use it for a wide variety of modeling use cases. It's not exactly, it works really well for machine learning and deep learning use cases, but it's not so purpose-built for those that you couldn't use it for reinforcement learning or simulations. From the perspective of kind of like use cases or industries that we work with, our product does, given the way that we've built it, it lends itself to companies that are building what a lot of our customers describe as more differentiated models. So models that will actually impact the business either from a revenue generation or a product differentiation standpoint. So these are the models that end up being really important for the accounts, are the most important to actually use in the context of Sigopt. So what they'll often do, companies that use our product, is they'll actually apply us to those models that are most important for them as a business, whether it's recommendations in media and telecom or trading strategies in algorithmic trading. So the core industries for us still today are algorithmic trading. That was one of the first areas where we landed. The second is what I'd call like enterprise technology, enterprise consulting. So in fact, some peers of PwCs are an example of this, who have, in the hundreds, if not thousands of data scientists and need really flexible tools that can help them meet really tight project deadlines without compromising the quality of the models that they're actually delivering to their end customer. The third is media and telecom. So bundling those together, which is a rather big group, but think streaming services, recommendation engines within those. One of the largest streaming companies in the world uses our product, and as well as some of the more classic kind of telecom firms that are starting to consolidate media companies within their broader umbrella portfolio. And they have similar problems that they need to actually apply modeling to, and need to actually apply kind of like a more performance kind of based approach to the way that they're developing models. The fourth is more traditional financial services and insurance. So whether it's your classic kind of credit card payments firms, your bigger banks, or some of the bigger insurers in the country, we kind of like think about a lot of their problems in the same vein, because there is some regulatory complexity there that actually impacts the types of models they're using. But the application of our product and the way that we can actually make our product delivery really obscure, and actually provide it in the cloud or on premises matters a lot to those companies. There's actually a long tail of other companies, but I'll land on the last one being in like industrial and oil and gas type providers, who, this is like actually an important use case for us, where if you have like a particularly expensive approach to either data collection or the modeling process itself, and you may need to run simulations, these are actually interesting use cases for us, because our approach, for example, to model tuning ends up being extremely efficient compared to other approaches you can use that are more naive.
Any great success stories that you could share?
The way that we organize our product, it obscures a lot of the information, both from us and in a way that like is privacy by design, so actually protects our customers. So often we'll speak more generally to different use cases. That said, the Two Sigma use case is an interesting one for a lot of companies that are migrating to a strategy where they are investing in their own internal modeling platform. And so their use case is interesting because they actually have a really sophisticated approach to the way that they model. I don't know a lot about it, actually. It's one of the benefits of our product to them. But what they have publicly said about our solution is that they really got three benefits out of it when they implemented it internally. The first is they were able to consistently get even better configurations of models using our parameter tuning solution than otherwise possible, much faster than they were able to get with similar solutions in this space. So in one particular case that they mentioned publicly, they had a model that was expensive. It took about 24 days to tune. They implemented our product as a comparison to that baseline, and were able to tune the model in 3 days instead of 24 and get better results in the process. Second benefit from using our product related to the way that our product enables exploration of new problems. And so they found that you're actually able to, as a team and as a data scientist, use our multi-metric optimization capability in particular to quickly compare different metrics and get a much better understanding of the problem that you were trying to address with your modeling approach. And that would actually help you with not only metric selection and metric definition, but actually help you with model selection as well, where you could have a much closer tie between your metrics and the overall outcome and impact that you expected once you put the model in production, because you're able to run much more efficient exploratory analysis looking at multiple metrics at the same time as you're running through the modeling process itself. The third benefit that they found related to scale. It's important for enterprises that are doing at scale work where they may need, let's say 1 million API calls in any given hour. They always need new suggestions for any tuning job in the order of milliseconds. And they may need to support a higher dimensionality of scale in the way that you're actually running a tuning job for any individual model.
Final question, and we're going to go a bit broader again. So what do you think are some of the challenges for the traditional companies, the ones that are not data-driven, that embark on the machine learning implementation journey?
I think there's a few interesting trends. Why don't I boil it down to a few trends that I've seen that I find pretty interesting across, generally, that I can generalize across the customers that we interact with. The first is the really rapid acceleration of both interest in and understanding of the really standard processes that companies need to get right to be able to do effective model development, but also efficient model development. So just a few years ago, even at some of the more sophisticated conferences, we would often, for example, get questions about hyperparameter optimization itself and like whether it was actually valuable, in what context was it valuable, what are different approaches to hyperparameter optimization. Now, the starting point for the conversation when we're at really any conference, even if they're less, like sophisticated user-oriented conferences or less technically oriented, will be past that base and really specific to the algorithms that you're using. It's just one example. And in general, we've seen a really big push around like understanding the standard components to doing this really well, especially around the software tooling that's required to actually enable data scientists. So there's been there's actually an explosion of different reports published on the standard components to doing modeling well and standard components going into a modeling platform. This is a trend that I see toward increasing standardization of certain tooling that is really important and vital to get right, so that you can enable kind of like a model-driven or modeling-driven organization. The second trend I see is that companies are becoming more geared toward and open to buying standard products to make it much more efficient for them to actually scale their modeling process. And then the third one that I see relates to this notion of using models and becoming model driven as a differentiator for a business rather than just as a cost saving tool. So the first wave that we saw was like really like kind of like analytics 2.0, where you wanted to apply modeling across the business as efficiently and as simply as possible to as many pretty solvable problems that ended up looking like cost saving problems and drive efficiencies within a business. And that first wave was pretty productive for the company. The second wave that we see and that we've worked with a lot of our customers around is designed to actually start to transform the business itself by either introducing models or intelligence into the way products are differentiated or operate, or apply models to revenue generation opportunities for the business itself, and use machine learning to actually impact not only the bottom line for the company, but top line. And what we see is when companies actually do this well, that's where AI goes from being kind of like a marginal, you got to calculate ROI on a project by project basis to see if it actually pencils out, to being a fundamental transformational part of the business and you're measuring impact, but you're no longer penciling out whether it actually is going to be net revenue or net ROI positive. The gains are so significant that you're actually just trying to, on the other end, you're just trying to scale as fast as possible and scale that approach as fast as possible. And so this kind of like third trend that we see is like a greater orientation toward performance, and really a greater orientation toward enabling modelers within a company, data scientists, machine learning engineers who have domain expertise, with the right set of tooling that is part of that first and then second trend, so that you can actually develop an edge with your machine learning strategy itself.
These were extremely important points. Nick, thank you very much for the time and the interesting conversation.
Thanks, Chip, and happy to do this again. I appreciate the time.